Fibonacci sequence by Ashutosh. Introduction. The Fibonacci sequence is a series of numbers 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, etc. The next number is found by adding up the two numbers before it. The 2 is found by adding the two numbers before it, 1 plus 1. The 3 is found by adding the two numbers before it, 1 plus 2. And the 5 is 2 plus 3, and so on. The golden spiral. When we make squares with the Fibonacci numbers as the width, we get a spiral known as the golden spiral. The squares fit neatly together in a golden spiral. Fibonacci sequence in nature. There are many examples of the golden spiral in nature. We can find examples in different flowers. Their petals grow in a spiral way, and the number of petals is a number from the Fibonacci sequence. The pattern of the seeds in a sunflower also follows the golden spiral. In a sunflower, the turn in between the cells values is the golden ratio, 1.61803. Golden ratio. Any number that is a simple fraction, example 0.75 is 3 by 4 and 0.95 is 19 by 20, etc. will, after a while, make a pattern of lines stacking up which makes gaps. But the golden ratio, its symbol is the Greek letter phi, is an expert at not being any fraction. It is an irrational number, meaning we cannot write it as a simple fraction. But more than that, it is as far as we can get from a fraction. There is a special relationship between the golden ratio and Fibonacci numbers 0, 1, 1, 2, 3, 5, 8, 13, 21. When we take any two successive Fibonacci numbers, their ratio is very close to the golden ratio. Golden ratio continued. So just like we naturally get 7 arms when we use 1 by 7, we tend to get Fibonacci numbers when we use the golden ratio. Try counting the spiral arms, the left turning spirals and then the right turning spirals from the figure below. You will notice that the numbers are from the Fibonacci sequence. Exceptions in nature. We don't see the golden spiral in all plants, as nature has many different methods of survival. A common example is the four-leaf clover. Four-leaf clovers are the result of a genetic mutation that overrides the three-leaf gene. These leaves are very rare and thought to bring good luck. Golden angle. So far we have been talking about turns, full rotations. The equivalent of 0.61803 rotations is 222.4922 degrees or about 222.5 degrees. In the other direction it is about 137.5 degrees, called the golden angle. The golden angle is taken by the seeds of a sunflower. The rule. We can write the rule. The rule is xn is equal to xn minus 1 plus xn minus 2, where xn is term number n, xn minus 1 is the previous term, n minus 1, xn minus 2 is the term before that, n minus 2. Example, term 9 is calculated like this. x9 is equal to x9 minus 1 plus x9 minus 2, which is x8 plus x7, which is 21 plus 13, which equals 34. Relationship between golden ratio and the Fibonacci sequence. When we take any two successive Fibonacci numbers, their ratio is very close to the golden ratio. In fact, the bigger the pair of Fibonacci numbers, the closer the approximation. For example, when we divide 5 by 3, we get 1.6 bar. But when we divide 377 by 233, we get 1.61, which is very close to the golden ratio. Thus, the bigger the pair of Fibonacci numbers, the closer the approximation to the golden ratio, which is known by its Greek symbol phi. Some interesting facts. Factors of Fibonacci numbers. On careful observation, we can observe the following things. Every third Fibonacci number is a multiple of 2. Every fourth number is a multiple of 3. Every fifth number is a multiple of 5. And every sixth one is a multiple of 8. Fingers. Looking at the length of our fingers, each section from the tip of the base to the wrist is larger than the preceding one by roughly the ratio of pi. Fibonacci first noted the sequence while solving a problem based on rabbit breeding. Terms below 0. The Fibonacci sequence also works below 0. In fact, the sequence below 0 has the same numbers as the sequence above 0, except they follow a plus minus pattern. It can be written like this: 1, minus 1, 2, minus 3, 5, minus 8, 13, minus 21 and 34. It goes like this: 34 minus 21 is equal to 13, 21 minus 13 is equal to 8, 13 minus 8 is 5, 8 minus 5 is 3, 5 minus 3 is 2, 3 minus 2 is 1 and 2 minus 1 is 1. Fibonacci history and discovery. Fibonacci was not the first to know about the sequence. It was known in India hundreds of years before. Leonardo, Pisano, Bogollo lived between 1170 and 1250 in Italy. Fibonacci was his nickname, which roughly means son of Bonacci. As well as being famous for the Fibonacci sequence, he helped spread the Hindu-Arabic numerals through Europe in place of Roman numerals. That has saved us a lot of trouble. Fibonacci Day. Fibonacci Day is November 23rd, as it has the digits 1, 1, 2, 3, which is part of the sequence. November 23rd recognizes the importance of the Fibonacci sequence in mathematics and our everyday lives. Thank you for watching.